Welcome. This is the sixth and final video about numerical summaries. And in this video, we're going to talk about the new measures of spread, range, and interquartile range. And we're also going to draw a box plot, which will give a visual summary of the 5-number summary. Visual of the 5-number summary. So our first two tasks are just to discuss these definitions, range and interquartile range. And range is often used as describing the interval, so from the minimum to the maximum. And here we're going to say the range is just going to be one number. It's that you get from a subtraction. We're going to subtract from the maximum the minimum. And the interquartile range will be very similar. We'll subtract Q1 from Q3. So they'll both just be single numbers that describe the breadth of the data that you're dealing with. Let's do that in the context of our example where the numbers are representing the areas of counties in Oregon. So the range is going to be Q4 minus Q0. And I just copied over our table from the previous video. 10135 minus 400, also 35, okay? And that will be an even 9,700, I believe. And so that's how wide the data set is. Notice the range doesn't, if somebody just tells you the range, you don't know where that 9,700 lays. It might be between 1 million and 1,009,700. And that would be a small range compared to the numbers that we're seeing here. So it does kind of need some context. And then the interquartile range will be Q3 minus Q1, which in this case is 3106.5 less 903.5. And that will leave us with what looks like about 2,203. Great. So the next question is, how many of the data points in the distribution fall between Q1 and Q3? So Q1 is larger than 827 and less than 980. So it's smaller than the 3 rows that I just sectioned off. And likewise, the Q3 separates off this. So it's all these numbers that are here in blue that are between the two values Q1 and Q3. And notice that's 50% of the data. So rather than counting them up, what we're really wanting to think about when we talk about the 5-number summaries is portions of the data. And we divide it into chunks that are 25, 50%. And between Q1 and Q3, it's always going to be 50% of the data. All right, so the next thing we're going to do here is define outlier. And in a previous video, we described the outliers are numbers that are more than 2 standard deviations above the mean or less than 2 standard deviations below the mean. Here we have another size metric, but we're not basing it off the median or the mean. We're going to take this IQR and multiply it by 1.5, and we're going to add it to Q3, and we're also going to take it away from Q1. And numbers that are more extreme, so on the outside of those values, we'll call outliers. So there's a lot kind of going on here with the 5-number summary, and what's helpful is to have a visual. So the next thing we're going to do here is produce that visual, and it's called the box plot. So the first thing to do when you're making a box plot is to make a number line, and the number line, is typical that we'll keep them on the horizontal, and we need all of our numbers to be able to be represented on here. So if we start with a 0 here, and we put a 1,000 here, what the linear bit about this means is that this next tick mark has to be 2,000. because we've already kind of determined that this distance is represented by 1,000. So every tick mark has to be worth 1,000. That's distinct from, say, a logarithmic scale, where distance does not translate directly to numbers. 6, 7, 8, 9, 10. Okay, so we got a little bit extra line over there. If we find some more data, we'll have some room for it. Okay, great. So we have produced a horizontal line with the values of the numerical variables spread linear. So, I mean, we could label that, right? That might be a good thing to do. This is, right, what do they call this? Square miles. And then it asks us to frame a box with Q1 and Q3. So at 903, we'll have one end of the box. Let's give ourselves a little bit a bigger box. And at 3106, we'll have another end of the box. So that's our box has been framed. And then the median is a dividing line. So at 1824. So we did that. And then the last thing is to draw so-called whiskers to the most extreme values in the data set that are not outliers. So we need to find the dividing line for outliers and then find the biggest and the smallest numbers that aren't outliers and draw lines that will go out to those numbers, and that will be what we call the whiskers. So one thing we need to do is determine what is and what is not an outlier. So let's do a little calculation. And we will need this table yet again, so let's just transfer it. Oops, we didn't need to cut it. I'll just copy it. Now that's funny, we didn't need all that, did we? So, let's calculate the outliers. Outliers are numbers larger than 1.5 times the IQR plus Q3. So that's 1.5 times, and then the IQR was 2203. And then we need to add that to Q3, which is 3106.5. So let's bring up our calculator. And we have 1.5 times 2203 plus 3106.5. So if you are larger than 6,411, then you are an outlier. Outliers are also smaller than, numbers smaller than, and here we'll take away from Q1 that same thing, the 1.5 times the IQR. So here Q1 was 903.5. We're going to subtract 1.5 times 2203. This is 903 minus 1.5 times 2203 equals negative 2,401. And if you're a county, your square area can't be negative. So in this particular case, it's impossible to be an outlier because your number is so small. So we're done with the calculator, and I want to point out that this part of the calculation is the same. It's this 1.5 times the IQR is being added to or subtracted from Q3. So the checklist here says that we need to draw whiskers to the most extreme values that aren't outliers. So there's this kind of dividing line, we can maybe use a different color, that says outliers on this side are all the things that are over here, and we really actually needed the room on the left side of this number line, but outliers, maybe over here as well. So everything that's between the two dotted blue lines is not an outlier. And now we just need to go to our data set and find the most extreme values that aren't outliers. On the small end, we already know what that is. It's 435, because 435 is the minimum value. So, that'll be maybe right around here. And the whisker just looks like a line, a vertical line, and then a horizontal line connecting back to the box. Let's go back to the data set itself to find the biggest number that's less than 6,411. We're looking for the most extreme value that is not an outlier. So 6,411 looks like that's at this dividing point. So numbers that are bigger than 6,411 are outliers, and numbers that are less are not. So 5,945 is where we draw that whisker to. And then it's right to make note of the outliers. So there's one at 7,940, at 9,888, and again, oops, that's not where that is. 9,888 is much closer to 10,000, and another one that's just over 10,000. And that is our box plot. So maybe we can do some more labeling. So this was Q0, Q1, Q2, Q3, and this one over here is Q4, but this is the maximum value that is also not an outlier. And the reason why it makes sense to do this is because you don't expect to have too many outliers. And that is, and what that means you can gain from the box plot quickly is an expectation that between any two vertical lines, you can expect 25% of all the data to fall. So even though between two vertical lines is a different amount of distance on the picture, you still expect 25% of all the data to fall between any two vertical lines. And because in a large data set, you don't expect too many outliers, you can still expect 25% within each grouping. So that's a visual of the 5-number summary. The interquartile range is a number that measures spread in the sense that if the interquartile range is large, then the data is probably more spread out. But if the interquartile range is small, then the data is probably all smushed together. I guess we can draw that onto our already crowded picture. But this distance right here is the IQR. And so if that number were smaller, and that's where 50% of all the data falls, that would mean most of the data was smushed together. And then we have this box plot that is just giving a visual of the 5-number summary. All right, that's it for numerical summaries. See you in the next section.